Hello everyone. Now we will be discussing about persistence, how to use the database, and we will be building the microservice, catalog microservice, and we will be using the product microservice. Okay, so let's start. I am in the editor. So let me change the settings a little bit so that this is visible to you all well. Okay, great. I will put my video to the bottom so that does not comes in your way. Okay, perfect. So let's start. I'm in the code repository. So this is my repo where I have the MicroProfile tutorial. I'll go to code directory. This is the branch name, which is code. I'm merging this into the main branch, so you don't have to worry about this particular branch. Now in this I have various chapters. I'm going to chapter 6. This is the place where I have the catalog service with database persistence already there. I'll just close all my previously opened file. Now I'm inside the chapter and the structure of the code, let me show you. So in chapter 6 we have the catalog project. In this catalog project we have Java folder. Then within this Java folder we have entity class. So this is the product entity class. As you can see here, there's a table, and then we have various named queries. Search product, find by name, find by ID, find all. So this is our named queries. Then there is product, ID, generated value, strategy, column, name, ID. So all these values are defined. We have validations with message. So here name cannot be null for a product. It cannot be blank, right? So if there is a message, the size should be 1 to 100 maximum. Product name must be between 1 to 100 characters. This is the message. So we have the column, which is name. So we have mapped this particular property of the class to this column. And similarly, we have defined the size of 500 maximum for product description, and we have also mapped it with the column. So there's another field which is price. This is big decimal. This is important because this helps in floating point calculation and more accuracy. You want penny by penny accuracy when you are dealing with numbers. So here it cannot be null. It can have minimum value 0.0. You can't have negative price. This is a good validation. And then you have precision. This is 10 and scale 2. Okay. So this is our constructor. We have defined the constructor, default constructor by ourselves. We could have created no-R constructor with the Lombok annotation, but I have not used Lombok because Lombok conflicts with the entity classes. That was the problem we were facing last time, and that's why entity manager was coming as null. So this manual setters and getters have resolved that issue of having the persistence not working or IDs not getting generated, and some problems which we were facing earlier. So this is a product class. We have other classes also. This is for health checks and all, which we'll be using in the later sessions. I will explain them later. Then you have the repository. So we have one repository which is in memory database. We have put this as a configuration. So we won't be immediately starting with the catalog microservice with repository. So here we will have the in-memory Java repository. Then you have, so basically if you see here, this is in-memory.java is an interface. So we have defined an annotation which is in memory, and this is retained in the runtime. There is target field and method. So here is the JPA repository. Okay, let's execute it because there are different annotations which are defined. And so you may have a in-memory annotation or you may have a JPA annotation based on what kind of repository we would like to use. In the first case, we will use product in-memory repository, which will be based on the in-memory, or you have here a list of product is stored in your variables or data structures within the RAM. And JP repository is something which is using to store the values in the database. And there is a common interface, and there is a repository type annotation. So there is a enum which is repository type. It could either be JPA or in memory. So this is how you kind of define the repository, which is dynamically configured to either use the database or in memory storage. So then we have a resource class which is exactly the same as earlier. So entity class has been modified to have the classes, attributes, methods defined without Lombok, validations and messages for the validation. And then we have the product resource. Product resource has various values. Okay, so here as we see, we have another config property which is maintenance mode, product service, and then we have get all products. So there are various methods. This has been annotated with Open API, so we will cover that also in the previous session, in some sessions. Then we have product REST service. This is no additional configuration. So this is all about the code which is for the catalog service. Okay. Great. So let's come to the source codes for all other. So if I go to the code, so you should understand we have here chapter 2 source code. Okay, let me run one by one all the source code. CD dot dot. I'll go to CD chapter 02. Okay, in the chapter 02 we have here MicroProfile REST application. We are using Java 17, right? Then we are using this project structure. There are REST endpoints. There's model class. There is basic validations. So MN liberty dev, I directly run this command. Okay. Okay, I have to go to the project folder. So I have cd mp ecom store So mvn, and we have liberty run. So we have this, we can open this in browser, the service is running. It's redirecting to port 5050. This port is forwarded in this particular URL. You see here 5050. This denotes that this is forward of port 5050. We have e-commerce MP store. This is the context root. Then we have products, which will give us the list of products in JSON format. But we have a base path API, so I should use API then products, right? And this is MP e-commerce store. And now you see this is the JSON returning all the products. So this is the demonstration of a simple web service which has basic product listing functionality and JSON serialization. So now I can stop this server. We will go to next section. So I will say cd dot dot, then cd again. I will go to chapter 03 to run the second project. Then I will say ls. I have a service which is called catalog service. Okay. And I will show you what is there inside this catalog service. So basically the same service I have created. So here is our file. I'll open the preview. Okay, I'll close this. I'll open it again. Yes. Now in the README we have all the instructions. So here the description. Right, so we have this persistence implementation, CDI qualifiers, database, Derby database, right? So we have a feature called MicroProfile Open API. Okay, this is I'm opening chapter 3, not so this was not the right one. Okay, I'll open again. Yes, so now I have the right README file open. So here if you see, we have the MP e-commerce store. It will have CRUD operations implemented and memory based implementation, and it has unit test and integration test and logging. So I will go inside the project folder cd. It's called MP e-commerce store. Okay, let me come out of catalog. Right, so we may not need the catalog. So we have the catalog project as well. So let's see, catalog projects persistence. Derby offers more robust implementation. So this is about the catalog project. We can quickly test this as well later, but let's test our MP configuration. So MP e-commerce store. I should have a POM file here, mvn liberty run, or I will say dev. But before that, let me close existing server if it is running. Okay, mvn liberty dev. This is the debug port, no worries. So we discussed about the interceptor, all other details in detail. You see more logs here because this is configured with interceptor. It is also configured with log, and there are ports. So again, this is running in 50/50 port. I'll open. So we will have here again the same path, and this will give you list of products. Right, so in this we can go to the resource. So here in this particular chapter we have implemented, I believe, more methods. Let's see. So we have the product, entity, resource and service. In the resource we should have the entire CRUD operations, right? So we have get method, get ID, post, put and delete, right, as you can see here. Okay, so this is our second version, and all these methods could be tested using the unit tests. Sometimes I put the web description also, but I think for this there is no web app, or yeah, this web.xml only. And in resources we have login.properties, and in liberty we have the server.xml. so this is our application with all the CRUD operations implemented. Now coming quickly to the catalog project. So here we have two important things. One is we have the logging for exit and entry of all the methods. So you see here everything is like entering method, and you have annotations for you have logs for exiting method, and we are printing the response, also the time it takes to complete the request. This is done using interceptor pattern. Now coming to catalog, so let me close this. Right, I will go to the other project, which is catalog. There might be minor changes which we have to do right now on the fly. So we will see this product entity. See, we have this product entity, data is there. We can remove this. Let's keep this as simple without Lombok annotation, and we can generate the getters and setters by ourselves, right? So the easiest way to get this generate getters and setters is by going here and say generate getters and setters. Correct. So here we'll get the getters and setters for all the methods. Correct. And same way we can generate a constructor, clicking, and we say generate constructors. So here we can generate an empty constructor. Correct. So this is important for our Lombok to work. For persistence to work. Now we have the repository. Its requested scope, request scope, persistence context. All other configurations are created here. We have the resource. We may not need all the methods. So find product is there, find product by ID, find all products, delete, update, create. And then there is a resource methods which will be defining the get method, post method, and so on. And then REST application. Then we have here pom.xml, where we should have the Liberty server configured with the Derby database libraries. Right? So the other stuff looks good to me. So let's compile mvn validate to validate the POM. POM looks good. mvn compile to see if the Java, there's no Java errors. I see some error. One compilation error, product resource 64.5 missing return statement. So let's go to this file. So here resource, within that we have not this resource, this is resources, this is the resource. We have to go to line 64. Okay, so here response is what is expected, so we should return here, return not found, like this, automatically got completed with the help of Copilot. Now let me try compiling again this. Some warnings are there, so overall build is success, but let's try to fix the warnings also. So there is some duplicate dependencies. So let's say this is line 105 in pom.xml. So let's fix this. So line 105. What's the problem? So here Derby tools. Then we have Derby share, Derby. So this dependency Derby is there. Let's see if it is there somewhere else. Yeah, here there is Derby database dependency. So this is what is repeated, this dependency it was complaining about. Correct. Now there is no such. Yeah, you don't need this entire stuff. We can just say Derby database. Now this problem should also be resolved. So let's see if this compiles. Mvn compile. No warnings, no errors. Now build successful. Now we will mvn liberty. Let's stop anything if it's running, just to be extra safe. Now mvn liberty I would say def. So we have the persistent.xml as well, right? So this is debugging port. Some errors are coming. Ambient server related error. I think these things could be ignored because these are warnings. I will go to the browser and I'll try to run this method again. This time it's a catalog service, so we have to change this to catalog API products. So again, this.em is coming as null. So this is entity manager related problem. So if I go to the bottom, I would see some error here. So there is this particular error which is coming. Yeah, let me see if we can quickly fix it. If not, then we move on. Because we will be seeing, I have a valid implementation in chapter 6 where we will be covering persistence in much detail. Yeah, so SQL import script has to be created. This is right because this will import script is there. So this will populate the database. Awesome. Yes, so perfect. It's going in the right direction based on my knowledge. So it's trying to simplify also some other configuration files. So okay, maybe something this is not needed. Target database, it's removing. So this is JPA persistence provider. Okay, so let's do a clean rebuild, it's suggesting. So let me close this. The existing server running, I'll stop. Right, now I can continue. If it works, then we will commit the changes. There were few changes. One is import SQL. And then this optimization of persistent.xml. Good. So no compilation errors. everything built well. So it's suggesting to stop the server. Okay, we already did that, so this is good. Next, we should restart the server. Right, so we'll ask it to run liberty dev. Yes, so now it has fixed this command. I'll run it here. So seems to be running well. So far no warnings and errors. So we have JSON binding, JSON persistence, RESTful web services, debugger is running. The database script should got executed. Some exceptions are there. Let's see if there are any problems, because the comments could be a problem. Okay, so you see here some errors and some warnings are there in yellow. Sometimes it's okay, sometimes not. So the server is running. Let's check it. So let me go to the ports. Try one more time. And we go to products, but through catalog. This is a catalog service. And we get this entity manager error again. So not sure. This was required to be removed. Target database value derby. Right, so let's say this we don't want to change. This is good. And in this, this looks good. Values we have added. ID will be generated automatically, and we don't want this comments. Last time I remembered this was causing some problem, and at the end these semicolons are also not required in Derby. So these are some of the changes which we should do, and I will save it. Let's see. Okay, now I go to terminal. There has been some change. There is updates here. So is that solving the problem? Because this is during the initialization phase. So let me run again this command. This is the final try. We'll get back otherwise later. So just warnings, no errors as of now. So there is catalog API products. Still it's running. So this is OSGI related problem. Let me see if they can fix, Claude 4 can fix it. This should be related to the CDI scope or to bean. So they may be recommending to add a bean.xml or to update the scope. So we are going in the right direction, so that's why I'm kind of staying here. Okay, so continue. So it's cleaning the project and it will be running the So that OSGI error seems to be gone. Or is it appearing when we call the service? Okay. So same problem. Entity manager is null. So I'll undo this. This is feature. The removal I will also undo. These configurations also, I'll just remove it because I don't think they were necessary. So same entity managers null is coming. We will fix it in later chapters. So let me stop this server. Okay. Now coming to chapter 4. So we need to go one below. Now I'm in chapter 4, and anything if we want to commit, we can commit quickly. So changes which are there, pom.xml, making some changes here. This is nice. Yeah, these two changes are good. I'll put them in staging. Then we have the product Java. So we removed the Lombok and we created getters and setters. Looks good. Some additional spaces got added. So we'll keep this as well. These we did manually. Then we have product resource. We added the response. This is also good. Persistent.xml, logging. This is logging level, SQL find, whatever. Yeah, looks good. No worries. And then we have the import SQL. This also seems good to me. Okay. So these changes, let's commit. So now let's move to chapter 4. In chapter 4 we have, let's go to the files. We have a catalog service. So catalog service has product resource, product application, repository, entity. So this is again the in-memory implementation. No, this is a persistence implementation in chapter 4. Okay, let me go to chapter 4. Yeah, this is again the normal implementation where we have Java. Let's see, entity, resource, repository, product repository, everything. So let me try running this catalog project. So here, let me go to CD catalog. Liberty, ambient, let's say validate. Should be fine. Yeah. Ambient compile. Ambient liberty stop. Anything if it's running should be stopped. Right. Now we say ambient liberty dev. So see what all services are there. So again the CRUD operations are there. We have a readme file also. So in the readme I see mention about get all products implementation and implementation of open API. So here we have the open API Swagger documentation. So here if I go to the resource, and in the resource we will have Swagger. So you see here there is a tag, so there is a documentation which is now sprinkled over our existing APIs. So get method, it has summary of operations, right? So these are the Swagger documentation. These are the open API tags or annotations which have been added to our existing methods. This will generate an open API documentation which will be machine readable as well as human readable. So let me show you what does it mean. So here I can go to open API. Let me see if it's running. Application catalog updated in minutes, and what is the port which is used? 9080 is the port which is being used. So here I have to replace this. So let me go to the ports. Shows 50/50 only. It's catalog. Here open API /UI. So some problem with this, let's see how do we resolve. So there is a MicroProfile configuration which has to be there. So MicroProfile configuration property mp open API.scan equal to true. So this is good. So I'm just checking the logs, what's happening. Let's see if all the features are there in server.xml. Now in the catalog we should have resources, I don't see the liberty server.xml, because should be within src, then web app, not here as well, order src. Within Java there should be a liberty folder, or is it resource? So here, if we see in the previous projects, we have src, then main, and then within Java there is a liberty, and then we have lib, and we have the server.xml as well. So catalog src main Java, and the same we have new liberty config, and within liberty config here we can create a new file, server.xml, and in this we can paste this particular code. So same configuration, mostly Restful, and we need here open API. So feature, we say open API. Yes, we don't need to specify the version because we have provided the platform versions, and that's all. This is saved. Now we will we have to restart. This is what it's indicating. So the server, Liberty server, tries to indicate whenever it needs restart. If not indicating, then that means it might be, so it says open API could not be obtained. Okay. So the open API feature, we have payment service, we can verify from some other service where we have this defined. So in later chapters, for example chapter 5, we would have, say in catalog service, src liberty server.xml mp open API. This is the way it has to be put in. So I save it. Now I'll run this again. So now we will have the documentation. It's not just the documentation, it is an interactive documentation. That means you can call various REST service is using the documentation. So I'll show you. You will understand in few minutes what I mean by seeing the example. So now I go to the server. I open the web server is running. Then we have a catalog service. Then we have the products. This is our REST API. This is what is running in our server. But let's look into the documentation. So let's first look into the Open API endpoint. It gives a YAML file which has the documentation. So this is a machine readable documentation. It's a contract for our API. For human, this is human readable documentation, and it is interactive documentation. That means it shows the endpoint. It shows various operations, their details, their parameters, responses, even example of responses, schema of JSON which we have to send, and we can try it out by just clicking on try it out and execute button. This will execute the API and we see the JSON response here, right? So this is useful. We could test with the existing browser interface, but put, post, delete, there's something tricky, and this we can test. Say iPod, or yeah, say, then I will put Apple iPod Pro, whatever, and then some price, $199.99. So I have put some JSON, which is the request body. I can execute. Let's see the output. It has created a new product, ID 4, correct? And this is, we can verify with the get response also. I should see the fourth product. Yeah, you see here, this is what we added just now. Now next thing is we can update it using put APIs. So let me call the put, and then finally I will delete it. So there are other APIs as well. This is the put. So we can test this. So we will try it out. I'll say the ID number 4 is what I want to modify. I don't want to modify the ID. Don't want to modify anything else. I will just say price $299. I increased it. And let's see if some validation is happening. So yeah, you see here response for $299 is there. And if I go to execute, so the name and description are removed here, right? Which is basically a patch would have been a better method here. So let's see if there is put, and then we have delete. So let's delete this last product, 4 product. I'll say try it out. It says 4, and I execute. So this is executed. Okay, so product deleted, 204 is the response which I received. And if I call again the get method by clicking in execute, I should see 3 products, 4th product is removed. So this is the interactive documentation, which is previously known as Swagger. Now it is called Open API, and in MicroProfile, with the help of some annotations, just annotations, you can generate very nice documentation which is both human readable and machine readable, and it is interactive as well. It can be used for testing purpose and various other purposes as well. For example, if a developer, they want to see the contract, they want to try it out, or train themselves, this is very helpful. So this is about chapter 4. Now we've come to next chapter, which is chapter 5. In this chapter, so let me stop the existing servers. I'll move to the next chapter. Right now I will switch the directory. Now I am inside the chapter 5, where we have various services. So there is a readme file as well in chapter 5. This helps me to recall what is there in this particular chapter. We have various services. So it's asking us to run the services, various services. And then we can verify using the curl commands all the services. Right, so it has given us all the testing commands. So we have covered config, fault tolerance, health checks. So here we have matrices, OpenAI, REST client, various other features which will be demonstrated. Okay, so REST client is not yet demonstrated. OpenAPI we have already. Matrices, I think this will be covered in the next chapter. This is all about health checks. So health checks, we will be covering the payment service. Here we should have defined the health checks. So I'll go here and in the health check, so yeah, let me close this payment. Within that we have a readme file. So here payment service. So it handles payment processing. There's some configuration as well. Okay, so this is about configuration. So in this chapter we will be covering about configuration of a particular microservice, and this is all about external configuration. Okay, so same file we had as .md file, which we don't need now because we have this as a doc file. So I'll remove this. Yeah. So now we'll go to, we are already there. So I'll move to the payment service. In the payment service, I'll just first validate the form. Looks good. I'll compile the code. Okay. So payment service is running in 9080 port. So let's say start the server. Liberty. We will say def. So to demonstrate this particular service, again I'll close some unnecessary files which were open previously. For example, this one. We have this readme with this for the payment service, and now we will see this in a well format, documentation format. So our payment service is running. It's running in port 9080. We can go to another terminal window. Doesn't matter whichever folder you are, because we will be executing some commands which is mostly REST commands. So we will be checking the endpoints. So here we have various endpoints defined. So there is a payment configuration for a service as well, and this has these are the endpoints. So this is not a problem. So there is a method called payment authorize, which will process the payment. So building the application and running it, we are already done. Docker will demonstrate later. It's very straightforward. The project structure we know. I'll go through that later. Then we have these config service. And now how to test it. So we'll run these commands. So curl, then localhost. Since I'm accessing this from terminal, I can use localhost. So you see here in the JSON format, we have this configuration where payment gateway endpoint is configured as API payment gateway.com, right? Now I can update the configuration property by running a post command. So here I'll paste this new command. So here good thing is, again, I can run Swagger. So it will load. Yeah, so we have the Swagger. So we have this payment config. So we can try it out here. We can execute this and we will see that configuration. This is what exactly the same thing which we were getting in the curl command. We have authorize method. So when we run this authorize method, it's a straightforward. It's a dummy, no payment happens here. So it shows a success message. Okay, I come back here. So it now we can modify this configuration. We say this is new API gateway. Okay, so now this new API gateway configuration is updated. Even the message value, a lot of other details are also updated. And if I go to the other endpoint, you see here our method is also putting some logs. So here, for example, we say calling payment gateway API. This particular configuration is being written previously. Now since we have changed the configuration, here we have enabled another payment gateway. So this is also successfully updated. We can check that. Okay, sorry, this is we have called the authorize method directly. So this payment is successful. Also our payment config, it should reflect the new APIs. Yeah, so here new API payment gateway. And in our logs also, now you see here, it is not calling the payment gateway API earlier configured, it's calling the new API payment gateway configuration. So this is about how to dynamically configure application. So here there are various configuration options. We can configure a particular service using various options, which is the system properties or environment variables, or you can use database, you can use the configuration file. So here in SRC we have a standard configuration which is within resources, MicroProfile configuration. So here we can also update the configuration. So all these uh, different configuration sources have been defined different priorities. So the system variables have the highest priority, then the environment variable, then you have this configuration file, and then various custom configuration. We can also define, when we create a configuration source, we can define the priority as well. So that all is detailed out in the chapter for MicroProfile configuration. So this is about chapter 5. Now let's move to chapter 6, and now we will see persistence in action, as well as we will see health checks. So having seen this, we will move further. We have now another chapter, so I'll go switch to chapter 6. So I should say CD chapter 6, and then here I'll again go to the catalog project. Okay, ls, so it should have the POM, nvn validate. Okay, now I will have mvn compile. So compilation is successful. Okay. So this is the catalog. So now let me run it. nvm liberty dev. Okay. This has persistence created. So whatever values we will be updating, it will be available even after restarts as well. Okay, some errors are there, but this is good to ignore. Okay. Great. So we'll open in browser. So to quickly check if all the products are available, so we're getting the same error. EM is null. So this is chapter 3, not sure why. I'm running the wrong project then. I'll come out. Yeah. So that's the problem. I go to chapter 6. Here I should run. Yes. Correct. So in this we have the health endpoint also defined. We have the open API and persistence already also defined. So let me open. Okay, so quickly testing it. So we see there are products which get instantiated, right? We will have so many products now. because it's coming from the database. We have health also for this. So you see here, just a minute, let me confirm what's the health endpoint. Is catalog and then health, I believe. So let's try that. Okay. No, health is not here yet. For some other service, for example payment, it would be there. But let's move to Open API and then UI, so that we can try out all the CRUD operations. So here we have first method, which is list all products. I execute and you see all the products, right? We'll change the price of iPhone 15. Now it has become little old. We have iPhone 16 as well. So let's update this. So we have put method, which can be used to update a product. The ID for this is 1, correct? So we will have ID might not be needed here, but the other details we can change, or I'll take this copy from easiest way and then update here. And the thing which I want to change is the price is reduced to $8.99. I'm executing it. So you see here, this is changed. Okay. If I execute again, so you see the new field price is double. This is some strange behavior, but yeah, let's ignore this for so we have two variables. One is the price as double, correct? So $8.99, and I think we should put both of them as $8.99 to change this. Okay, so $8.99. Now if I execute this value has been changed, right? So now let me stop the server and restart it. So since this is persisted in the database, it will retain the value, right? But this is an embedded database. We are stopping this database and reinitializing it. Not sure, but can be checked very quickly. So let me stop this. Now I will run it again. So we have stopped and restarted the database server. The value is $8.99 or $9.99. That is something we'll verify. So now the service is running. I'll execute again. Hey, $9.99. Yeah, because we are using an embedded database. This is only for testing purpose. We are reinstantiating the database, right, reinitializing it as we are restarting our service. But yes, in theory, you know that in the database, these values will be, if you are using an external database, in the production, the database will be running and will be storing the data reliably, and you can retrieve whatever as update has been done. So now let's cover other aspects of health check. In payment, health check is important. So let's see what we can do in health check for payments. So here we have various endpoints. So in the README file, we have a documentation about using OpenAPI, using configuration, using all different data sources for configuration. Troubleshooting information also. So now I'm showing you the implementation for health check. So that would be demonstrated in catalog or payment service. I can refer the chapter content to know about it. Or you can look into the execution log, see where the health endpoints are created. So health 4.0 is there. So here 50-50 health, this was the endpoint, right? So here we should go to 50-50 and then health. So this is the health check for product service. So you see here first part is the status is up. We have checks, various health checks. So system resources, it's showing allocated memory, used memory, available memory, free memory, maximum memory. So the readiness check, startup check, all these checks are there. So this is demonstration about health checks. Now let's move to chapter 7. So as you see, more and more services are implemented as we move. So the chapter 7 was about matrices. So defining matrices. The configuration is used in multiple places. For example, we have a maintenance mode equal to true. That is a configuration which we put in microprofile configuration dot properties file. An open API scan. This particular configuration is also one of the configuration which is leveraged by Open API. This directs the server to scan for the Open API documentation. Right? This is about the maintenance mode, whether it's false or true. We can have a default value for the maintenance mode. So here it's defined and could be injected. So configuration property could be injected to a particular bean in the microservice. Bean is basically a object and which is managed by the container. And based on this value, you can take some logic or update your behavior of the microservice. So I'm just going through the documentation because there has been a lot of features which we have covered. So going to the exact place where we have details about matrices. So again, I didn't see the matrices implementation yet in the catalog. I'm checking in other places. So there's an inventory service, order service. There are commands described about how to use the order service. Payment configuration. So this is about the priorities. So we have the shipment service. Let me refer the chapter content to see where we will find the microprofile Matrices, we are covering 3 types of matrices, and this is covered in the product resource. So in the catalog service itself, so let's come to catalog service, and in the product resource, so we have Java, we have the resource file, and in the resource we will have the matrices. For get product, we have this matrix. So let me come to the get product method. There is a search. Get all product. Then we have the get product method. Get product by ID, basically. So we are looking into, I believe, chapter 6. Chapter 7 I should open. Catalog, Java, resources, product resource. So easier way to navigate is get product by ID. So you have here the matrix, which is time matrix. So this gives the product lookup time. So let me execute this. And see where are the matrices coming. And there is an endpoint. So let's run this. So we'll go to CD chapter 7, then CD catalog. I'll run mvm liberty dev directly. So demonstrating timed matrices. Now we'll call the get product by ID so that the matrix could be generated and then we can see it. Just waiting for the server to get started and then we'll hit the endpoint. Okay, debug port is set and database initialization has also happened. Now the service should be running in few seconds. Yes, the service is running in port 5050. I go to the same OpenAPI user interface. I'll call the method which is to get the product by ID. So this is the method which is get product by ID. I'll look up a particular product. Let's say I'm looking up for product with ID 4. I got the response. This is Samsung Galaxy S24 Ultra smartphone. Now to see the matrices, we'll have to hit the endpoint, which is 5050. Instead of here health, it is matrix. Correct? So if I go here, I'll get all the matrices. Many matrices are exposed by the vendor, which is the vendor for the Open Liberty server. So you see here scope is MP vendor, but we are looking for scope which is application, because we have defined these matrices in the application. So here is the scope of all the matrices at application level. So you see here number of times the list of product is requested. All these matrices are there, and project lookup time in seconds. This is what I get. 0.114 seconds is the product lookup time. Right? So here you have all the details of the matrix. Correct? We have also another matrix which is defined in getProducts. In the getProducts method, we have a counted matrix. So let's see that. Get all products. And in this we have some matrix defined. Let's see. This is the counted product access count. Number of times the list of product is requested. So let me call multiple times the get product method. So I go here, I will say try it out, I execute it maybe once, twice, right? Let's see what's the value here. We have to definitely refresh it. Now you see here product access count 2, right? Now let me call a few more times. 2 more times I've called. So now if I refresh, this should change to 4. Yeah, so you see here it is tracking how many times a method is called, a count of the calling. Then we have another matrix which is the gauge, which is showing the number of products which we have in our database, right? So let's see, we have the gauge, max gauge, right? And this is included in the method which is called get product count. So in this particular, we have the count method. We can try it out, we can execute it. So here it gives me the count. So we have 8 products. Now coming back here, I'll refresh. So you see here, last line, this is the gauge, right? So here you can say scope and name as well, name of the matrix. For example, we have this name, product access count total. So name equal to, so we can filter let me see. Yeah, so you can filter by typing the name and scope. This way you'll be able to access the filtered list, and if you have many matrices, you don't get cluttered with multiple matrices. So this is about the microprofile matrix. Now let me move to the next chapter, which is chapter 8, which is about telemetry. Let me take a small break. I'll be back. I'll have some water and then come back. And then we'll proceed to microprofile telemetry. So I'm back. Now we'll cover telemetry. In this we'll be covering Jagger tool for observability. So let me stop the server. Okay, I have stopped already. We'll move to chapter 8. Now I'll open the chapter content so that I can show you which exactly microservice to run to see the Jagger in action. Okay, so chapter 8 is about fault tolerance. So here we will be covering timeout, retries, fallback, circuit breaker. So all these different capabilities of MicroProfile fault tolerance. So we'll go to payment service. And in payment service, we have the retry mechanism. So we can test that. I'm running payment service. So we have put some random failures in the payment service. So I'll show you the code. So as we go inside the code, in chapter 8, I'll open the payment service. So here in the payment service, I go to SRC source. We have the entity payment details. Then we have the service, payment service. This is the important class where we have the fault tolerance. So we have the configuration here. We saw it in the configuration session. Now timeout. Timeout is 300 millisecond defined. There is a retry. There's a fallback. This is bulkhead. So this is all the various mechanisms which are implemented. So here we have asynchronous execution, timeout, retry, fallback, bulkhead. Right? So we can demonstrate it with the help of some test scripts. So we have a test script here. So as you can see here, this test script demonstrate MicroProfile fault tolerance patterns. So now let's first prove that this is asynchronous, right? So we will call these successfully multiple times. We'll call this using curl commands. So you can see here the authorized payment method will be called here in quick succession, and based on the response time which we will be getting, we will see that the response is very fast. This means that this is running okay. So let's do it one by one. We have scripts for various for each of these scenarios. So let me go to the terminal. So we'll go to the exact folder because we have to run some bash scripts. cd dot dot cd dot dot again. Now cd chapter 8. Then we have cd payment. Now we'll ls and we should see the scripts. So let's say test async. Okay, .sh. If we execute this, we'll be able to see that this particular method is getting executed. Okay, so we should have chmod plus x test async.sh. Now we will run this. So you see here there has been multiple payment requests which is made for different amounts. So here there is a fallback is also called. Sometimes if the failure happens, and then there is response which is coming. So fallback response in for scenarios where there is an error, sometimes it is successfully processed. Correct? So you see this is fast response coming. So that means this is executing asynchronously, and now all the response has come. Right? So if there is an error, we have fallback. So again, chmod plus x now I'll run this, sending 3 requests in succession, and then we'll get the response. So this is completed. So rapid response types indicates non-blocking behavior. Multiple processing entries in log show concurrent execution. So yeah, this is also printing the logs. All asynchronous methods return quickly while processing continues in background. Right? So same we can execute other now Okay, so there was a method called test payment basic. Then we can check retry scenario. So here the first payment was processed in first attempt itself. Here 3 retries were required because few times it got failures, and here there was an exception, so there was some error, and this was non-recoverable error, that's why it is coming out again, non-recoverable error. Then amount is missing, so no retries in case of some exception. So this demonstrates that we can configure that only some temporary errors can be retried, and some errors which are non-recoverable, they should not be attempted for retries. So here all these retries are happening, 2 retries, then successfully done. So this ensures that your service is more stable. In case of failure also, it will be able to process the payments in a resilient way, right? So with different number of calls, we got different number of retries based on failures which were occurring, and I simulated errors using some random number, random variable.
Come, beta. Papa, are you doing work now?
Yes, I'm in the recording mode. So this is about retries. And then we'll test the bulkhead. So here we have set the bulkhead capacity as 5. There is asynchronous processing, and we have the retries as well. So we will be sending 10 requests. So you will see that after 5 requests, the other request will be in the waiting queue, right? So yeah, it's initially attempting to clear few requests, then we are waiting. So here is the key observation, that after a certain limit the requests are rejected. So this is the test script to demonstrate the bulkhead. So there are various test scripts to show the execution of various fault tolerance features. Now let me close this from the terminal.